Hi, 8th grade students. We are going to wrap up lesson 1 in module 2, post-secondary proportions. We're going to complete activity 1.3 and activity 1.4 in this video. So we've seen different representations of proportional relationships. We've seen it in a table, in a graph, and as an equation. This activity is going to review those things. So it says Deja attends college in another state. During summer break, she drives home from college to visit her family and friends. Deja decides to keep track of the time it takes her to drive home from school. She records her distance after various numbers of hours. Her data are shown in the table. And they're first asking, does this table represent a proportional relationship? Explain it. So in order to represent a proportional relationship, we need to see a constant ratio in the table. So the distance, this actually depends on the number of hours she drives. So the distance is called the dependent variable in this case. This is the independent variable. So we need to look at the ratio of distance to time. I'm going to write out all these ratios as fractions. And if we were to actually divide these fractions, we would find that all of them are equivalent and they all end up equaling 60 or 60 over 1, meaning 60 miles per 1 hour. So this does represent a proportional relationship because of the constant ratio. Part B says write a ratio for distance to time. So we've already done that up part A. We kind of did both parts for part A, but again, here are all the ratios, distance to time. It says just write one of them. We'll just write all four of them out. And then part C, it says write the unit rate for distance per 1 hour. And it tells you in the bottom left corner of your book on page M2-14 that a unit rate is a comparison of two quantities in which the denominator has a value of 1 unit. So these are all rates. We're comparing distance, miles to hours. Unit rate means how many miles per 1 hour. So we're only interested in 1 hour. To do that, we can take any of those ratios and just divide it. Do the division here. So this literally means 180 divided by 3. That's going to give us 60, and that represents 60 miles per hour or 60 miles over 1 hour. And that would be the unit rate, 60 miles per hour. So now we're going to move on to page 15 on the next page. It says one of Deja's high school classmates, Tamar, attends college with Deja. He also drives home during the summer break, but takes a different route. Analyze the graph of his trip. Does it represent a proportional relationship? So here's his trip. Looks like it's a line. Looks like it's going through the origin. Therefore, it is a proportional relationship. The graph represents a proportional relationship because it is a line through the origin. Make sure you copy that down. That's what we're looking for on a graph. Line must go through the origin. Part B, who drives faster? Well, we know Deja from our work on the previous page. She drove 60 miles per hour. That was her unit rate. So let's look for Tamar's, which is we want to know how many miles per 1 hour. So let's find 1 hour. Here's 1 hour on the graph. So we're actually looking at that point right there, and that looks like it's 50 miles per hour. So that means Deja drives faster because her unit rate is larger. She drives 60 miles per hour, Tamara's 50 miles per hour. Now we have a third friend, Alicia, offers to drive Deja and Tamar home for spring break so that they can share the cost of gas money. When asked how fast she drives, Alicia reported that the distance traveled y for the time x can be expressed as y equals 57x. I'm sure that's how most people would share how fast they drive, right? They'd give an equation. I know that's not very realistic, but here's the equation that represents Alicia's distance in time. Does Alicia's represent a proportional relationship? Yes, it does, because it's in the form of a proportional relationship. Alicia's equation represents a proportional relationship because proportional relationships are always in the form y equals kx, and that's what we have here. Compare the three friends. Who drives the fastest? Well, let's talk about Alicia. If Alicia's equation is y equals 57x, then that means that her unit rate or her constant of proportionality is 57 miles per hour. So who drives the fastest? It is going to be Deja. She drives the fastest because her unit rate is the largest. And now it wants to rank them in order from slowest to fastest. So we're going to start with slowest, and we're going to work our way up to fastest. So slowest would mean the smaller unit rate, which was Tamar. Tamar was 50 miles per hour. I'll even put it in parentheses here. Next was Alicia. She was 57, right? 57 miles per hour for Alicia. And Deja was the fastest at 60 miles per hour. And that completes activity 1.3. Now we're going to look at a similar proportional relationship here with a recipe. It says students in a sculpting class at a university are working in teams to create modeling clay. The students learned that they can make different types of clay by changing the ratio of flour to water. Their recipes are shown in the table. How many different recipes for clay did the students create? Show all work and explain your reasoning. Now, just because there's 7 groups doesn't mean that these are 7 different recipes. So by different recipes, they're really talking about different ratios of flour to water. So if you look at the ratio, the cups of flour to the cups of water, group 1, group 3, group 6, and group 7 all have a ratio of 5 cups, or I'm sorry, basically 2.5 cups of flour to 1 cup of water. All of these would simplify to this right here. So there's one recipe. Another recipe is represented by group 2 and group 5. Both of those recipes simplify to 3 cups of flour to 2 cups of water, or 1.5 cups of flour to 1 cup of water. And then there's actually one more here. We have group 4, where it's 2 cups of flour to 1 cup of water is what the simplified unit rate would be. So when we're talking about how many different recipes, there are 3 different recipes. I'm going to put in parentheses ratios. These are indicated by the different colors in the table. The art professor would like all of the projects to include the same shade of orange. The students have learned that orange paint is created by mixing red and yellow paints. 3 groups presented suggestions for the shade of orange to be used for the art projects. So we have Avi's group, Xander's group, Paul's group. We have an equation here, we have a table, and we have a graph. So it says, explain how you know that each group's proposal represents a proportional relationship. Well, Avi's is in the form y equals kx, so we know that it's proportional relationship. Avi's group presented an equation in the form y equals kx, so we know it is proportional. The next group, Xander's group, well, we have to look a little more closely at Xander's. We need all of these ratios to be the same, right? So we need this ratio to be the same as this one, and this one, and this one. And I'll take some of the easier ones like 8 to 2, 12 to 3. Those are all the same as 4 to 1. So all of these actually do simplify to that same thing. So we know that there's a constant ratio. So for Xander's group presented a table with a constant ratio, so it's proportional. And then the last group is probably the easiest one to identify that it's proportional, Paul's group. So Paul's group presented a graph of a line through the origin, so we know it's proportional. Excellent. So we've seen the three different representations here again. Rate the group proposals from lightest orange to deepest orange, and they tell us that the greater the ratio of yellow, the lighter the shade of orange paint. So let's first of all figure out that information, and I'm going to go back to right here. So Avi's group was 4/5 was the constant of proportionality in that equation that they gave us, right? 4/5. So for Avi's group, that means 4 parts yellow to 5 parts red. For Xander's group, we had this 4-part red, 1 part yellow. So if we just switch the order to stay consistent here, it'd be 1 part yellow to 4 parts red. Now for this graph, we need to identify some lattice points here, and preferably a unit rate if possible. If not, it looks like this is probably a pretty good point right there. That represents 5 red, 3 yellow. So for this one, we have 3 yellow to 5 red. So back to question number 3. The group with the lightest orange is actually going to be Avi's right here, 4 yellow to 5 red. Here we go. So Avi's group is the lightest. Next, it would be Paul's group. And then the deepest orange would be Xander's group. And again, Avi's group was 4 yellow to 5 red. Paul's group was 3 yellow to 5 red. And Xander's was 1 yellow to 4 red. So this would be the darkest, this would be the lightest. Write an equation where X is the amount of red paint and Y is the amount of yellow paint that would create a shade of orange that is between the two deepest shades. So the two deepest shades, Xander's was 1 to 4. Paul's was 3 to 5. We need something in between there. So just some fraction in between those two fractions. And when we say write an equation, remember it has to be in this form, y equals kx. So an example of a fraction that would be in between these would be 1/2. So k could be 1/2. This is just one example. There are other examples, other options here for the equation, but there's just one example. So that is a wrap on lesson 1, post-secondary proportions. Got an idea and introduced to the 3 different representations of a proportional relationship: table, a graph, and an equation. So I hope that helps you. Make sure you complete those pages during this video. You can always go back to it as well. Have a great day, everyone.